Hey boys and girls, today we're going to learn about statistics. So what exactly is statistics? Statistics is the study of data, how to collect, summarize, interpret, and present it. To start, let's think about how we could describe data. Let's say you have a set of numbers that describes the height of students in inches, and the heights are 50, 53, 54, 54, 49, and 46 inches. Well, let's say someone asked how tall the students are, and they want to have one number that represents all of the different heights. And you might say, well, how are we going to do that? Maybe you want a typical number, or a number that represents the middle, or the most frequent number, or even a number that represents the center of all the numbers. And this is where the heart of statistics is. We'll start by thinking of the concept of average. When people talk about average, they're talking about the arithmetic mean, which we will get into shortly. In statistics, average is actually just a typical or a middle number. And the average that you might be familiar with is arithmetic mean. And arithmetic mean, by definition, is just a sum of all of the numbers divided by the number of numbers. Okay, so what is the arithmetic mean of the numbers that represent the heights of the students? Well, we can first add them up. 50 plus 53 plus 54 plus 54 plus 49 plus 46 equals to 306. So that's the sum of the numbers. The number of numbers is 6. Then 306 divided by 6 equals 51. That means that the average or arithmetic mean of the heights of the students is 51 inches. Another way to represent a set of numbers is through the use of a median. And the median is essentially the middle number in the set. So if you order the numbers in the set from least to greatest, the middle number is the median. Given that, what's the median of the heights of the students? Well, we first need to order the set from least to greatest. 46, 49, 50, 53, 54, and 54. Okay, so what's the middle number? We have an even number of numbers, 6 numbers, so there's not a singular middle number. We actually have 2 middle numbers, 50 and 53 in the set of 46, 49, 50, 53, 54, and 54. And in this case, when you have 2 middle numbers, you have to go halfway between these 2 numbers. You're essentially taking the arithmetic mean of these 2 numbers to find the median. So the median is going to be halfway between 50 and 53, or 50 plus 53 all divided by 2, which is 103 divided by 2. If we convert that to a mixed number, we get 51 and 1/2. If you have an odd number of numbers, then you will have a singular middle number. For example, in the set 1, 2, 3, 4,
5,
the middle number is 3. So it's exactly in the middle. The third way to represent a set of numbers is through the use of mode. This is probably the one that you may not have heard of yet because it's not used as often as the other two. So the mode is the most common or most frequent number in the set. It's the one that shows up the most. But if there is no common number, then you have no mode. And we'll take a look at some examples of each case. Okay, so given that definition of mode, what is the single most common number in the original set? Well, 50 shows up once, 53 shows up once, 54 shows up twice, 49 shows up once, and 46 shows up once. Then the most frequent number, or the mode of the set, is 54. Okay, but what if we had the set 1, 1, 2, 2, 4, and 5? 1 shows up twice, 2 shows up twice, 4 shows up once, and 5 shows up once. In this case, we have 2 frequent numbers, which means the mode of the set is actually comprised of 2 numbers, 1 and 2. We call a set with more than one mode multimodal. Cool! Now, let's take a look at the following example. Find the mean, median, and mode of the set of the numbers 3, 10, 11, 8, 23, and 17. Let's start with the mean. Adding the numbers up, we get 3 plus 10 plus 11 plus 8 plus 23 plus 17, which equals to 72. Dividing by the number of numbers, or 6, 72 divided by 6 equals 12. So our mean is 12. Next, the median. Ordering the numbers from least to greatest, we get 3, 8, 10, 11, 17, and 23. there are actually two middle numbers, 10 and 11. So, like we said before, we could find the halfway point between the two, or the arithmetic mean of the two numbers. Then, 10 plus 11 all divided by 2 equals to 21 divided by 2, which is equivalent to the mixed number 10 and 1/2. The median is 10 and a half. Finally, the mode. It turns out in this case that there is no frequent number, which means that the set doesn't have a mode. Now, you might be wondering, are there other ways that you could represent data? As it turns out, there are. Here we have a list of students' score on a test. So, Alice scored a 90, Barbara scored 100, Charlie scored 100, David scored an 85, and Ethan scored a 95. This table is one way to represent data. Data is recorded information. It could be quantitative, quantity, or qualitative, quality. In this case, we have quantitative data, numeric data that represents students' scores. You can also represent this data in other ways. You could record it as a bar graph or a histogram. So you could put the scores on the vertical axis here, and then you could put names on the horizontal axis here. And so the scale would be based on the lowest and highest scores you could get on the test, which we are assuming to be 0 and 100. So the way you read this graph is if someone asked you what Barbara got, you would go to the horizontal axis, look up Barbara's name, and then find her score based on where the bar ends vertically. That's pretty neat. But here we're assuming that we had all of the information we needed, the scores and the names of the students who got each score. What if you were just given the scores of the students but had no way of assigning meaning to it? Well, you could consider showing the frequency of the scores. Instead of writing the names, you could write the scores on the horizontal axis like so. The graph tells you how many people scored each number. 0 people scored 80, 1 person scored 85, 1 person scored 90, 1 person scored 95, and 2 people scored 100. That essentially has the same data as the list of numbers 85, 90, 95, 100, and 100. So it's just another way of representing it. And once the data is arranged in a more suitable way, we could start to ask ourselves interesting questions like, what's the range of the data? And range is just the difference between the highest and lowest data points. So the range of the data is 100 minus 85, which is 15. Another type of data representation that I want to focus on in this video is box and whisker plots, or just box plots. Box plots display a 5-number summary of a set of data. These 5 numbers are minimum, first quartile, median, third quartile, and maximum. When constructing a box plot, we draw the box from the first quartile to the third quartile. The vertical line of the box is at the median. The lines to the points, or the whiskers, represent the minimum and the maximum. So the minimum is essentially the smallest data point, while the maximum is the largest. The median, like we learned earlier, is the data point in the middle. The first quartile is the median of the data points between the minimum and median, not including the median, while the third quartile is the median of the data points between the median and the maximum, also not including the median. So let's take a look at an example. Construct a box and whisker plot for the following data set: 16, 12, 45, 60, 97, 100, and 102. Let's first order the data set from least to greatest: 12, 16, 45, 60, 97, 100, and 102. Now let's identify the 5 numbers. Minimum. The minimum is 12. Maximum. The maximum here is 102. Median. The median is 60. First quartile. The median of the numbers to the left of the median is 16. Third quartile. The median of the numbers to the right of the median is 100. We construct the box and whisker plot as follows. Draw a number line where the distance between each mark is 5 units. Next, draw a box between the first and third quartiles. Then, draw a line where the median is. Finally, draw lines to the points that represent the minimum and the maximum. Oftentimes, statisticians like to calculate something called the interquartile range. The interquartile range is the difference between the first and third quartiles, and it represents the middle 50% of data when ordered from least to greatest. The interquartile range of the data above is 100 minus 16, which is 84. It's often seen as a better measure of difference than the range, which we talked about earlier because it won't include outliers. But what exactly are outliers? An outlier is simply a data point that's distant from other data points. Let's take a look at some examples of how an outlier affects the mean and the median of a series of numbers. 5, 25, 34, 29, 30, 33, and 28. So, as usual, we first order the set from least to greatest. 5, 25, 28, 29, 30, 34, and 35. And you might already notice that the 5 seems to be the outlier since the other numbers are in the 20s and 30s. We can easily find that the median is 29. The mean of these numbers is 5 plus 25 plus 28 plus 29 plus 30 plus 33 plus 34 divided by 7, which equals to 184 divided by 7, which equals to 26.28. Okay, so what happens when we remove the outlier? Now, our set of numbers is 25, 28, 29, 30, 33, and 34. The median is the average of 29 and 30, or 29.5, which is larger than the original median of 29. The mean of these numbers is 25 plus 28 plus 29 plus 30 plus 33 plus 34 divided by 6, which equals to 179 divided by 6, which equals to 29.83. This also happens to be larger than the original median of 26.28. Interesting. So, when we remove the outlier, which in this case was significantly less than the other values, the mean and the median went up. Another example we can look at is when an outlier is significantly larger than the rest of the numbers. So we have 39, 37, 36, 34, 40, 38, and 76. And you'll notice that 76 is our outlier. So ordering the numbers, we have 34, 36, 37, 38, 39, 40, and 76. The median here is 38. The mean is 34 plus 36 plus 37 plus 38 plus 39 plus 40 plus 76 divided by 6, which equals to 300 divided by 6, which in turn is 42.85. Now, removing the outlier, we have 34, 36, 37, 38, 39, and 40. The median here is 37.5, smaller than the original median. The mean is 34 plus 36 plus 37 plus 38 plus 39 plus 40 divided by 6, which equals to 224 divided by 6, which equals to 37.33, which is also smaller than the original mean. This time, when we remove the outlier, which in this case was significantly greater than the rest of the values, the mean and the median went down. Alright, so that covers the basics of statistics. Remember to keep practicing.